presentation is Gaining 20/20 Vision During an Incident with PowerShell. This talk revolves around the use of PowerShell and supporting aspects as a suitable solution for incident response solutions for endpoints in your environment, to include shortfalls of the language. Our presenter, Fernando, is Fernando Tomlinson.
All right, so welcome to BSides Augusta. Man, this is awesome. All right, something like 1,000 tickets plus sold right here in the CSRA. As Josh said, we're definitely going to be using some PowerShell, talking about some incident response. Not really a 100% solution, but definitely giving you some visibility where you may not have it. So, again, Fernando Thompson, been with the DoD roughly 18 years. Started off my career as a system administrator dealing with domains and enterprise services, and then roughly the last 6 years been in what we know as cyber operations, if you will. Currently, I'm a technical director of a cyber operations center. Previous to that, I was leading the incident response team. And since we're in Augusta, I'm an adjunct at Augusta Tech, so I see some of my present and current students in here. All right, good to see you all. And definitely a PowerShell enthusiast, doing a little bit of red and blue team type tools for the last couple of years. Just recently, the PowerShell Conference Book Volume 2 dropped, so I'm a co-author in that. Definitely hope that you support that. We make no money from it. It goes to support underprivileged, underrepresented individuals, giving them a start in cybersecurity, right? Stuff like these conferences, not everybody can afford them, so all proceeds from that go to that cause. And then if you're interested in connecting, you see a couple of sites of mine. I'm definitely looking to interact with everybody outside of this organization as well. All right, so here's our agenda. All right, we're going to talk about, again, not all inclusive, but we'll talk about a number of great things that we could use PowerShell for to get after our incident response task and purposes. Now, why are we really here even talking about this? Well, there are some things we can see coming, then there's other things we can't, right? But at the end of the day, no matter what happens, we have to react to it. So in this case, all right, don't really necessarily have the ability to see it coming. What you do, you see the train coming off the track, and at that point, you're trying to react. Now, if that's not you, if that's not your organization, maybe you have a plan, and definitely kudos to you. But guess what? Not all plans go as we desire. So even when we have a plan, the execution of it may not end in the manner in which we desire. That leads us to incident response. All right? And when we look at what that really means, we kind of look to three reputable cybersecurity organizations in this field. And while their definitions are slightly different, overarchingly, they're roughly the same. When we look at the actual phases, we'll look at NIST, right? National Institute for Standards and Technology, and we'll look at SANS, another company in this field. Right? We see NIST has it broken down into 4 phases, while SANS has it broken down into 6. And largely speaking, those are almost one and the same. They just do them at different points. And when we look at how that really maps to each other, it's like so. So this whole preparation of sorts. Now we're talking about identifying the people, the training, the exercises, the SOPs, really understanding what it's going to take for us to do an incident when it happens, because it's a matter of when, not necessarily if, right? Putting together our jump bags, so when that fire happens, we just grab and go. Then we look at the whole identification perspective, or in this case, identification, detection, and analysis. And now this is the point where we're looking for indicators. We're proactively trying to find these things, whether it's from an endpoint perspective, network analysis. The data is data, right? The more we collect, the more we just need to sift through it. As you heard the keynote speaker, sometimes there are diseases in our organization, and we may not know that we're in need of some type of healthcare. So we have to proactively go out there and look for it. And then once we find it, now we have to kind of understand it and contain it, right? We may do that by isolation. We may do that by neutering whatever the process or whatever is being used to kick off that thing as a whole. But really, there's no fine way for us to do it. And once we get to that point, now we have to eradicate it. How do I cure myself of this cancer, if you will? And once we've done that, now this is a touch point, because if we do this too soon, we show our hand to the adversary, and they're probably going to go dormant, or they're going to come back stronger than they were before. So you kind of have to do this in a concerted effort. You have your incident response team, but really everybody in that IT staff and other parts of the organization have a point to play in this as well. Once we have that, we look at how do we get the organization back to where they once were before the intrusion, whether that's restore from backups, patch, what have you, a number of things. And never take or never use never let a good crisis go to waste. So we want to really highlight the lessons that we learned, because every incident is an opportunity for us to learn, so we can then put it back into our cycle for the next time this happens. So largely speaking, hilltop perspective, that's what we have. But really what we're going to focus on in this talk is really these areas, right? How do we identify, really detect it? How do we contain it? And how do we kind of eradicate it? Some common approaches is using some type of device, right? Could be open source, could be commercial. Now, I'm a fan of both, but I would tell you, depending on your organization, as a previous incident responder, I go to some organizations and they have the latest and greatest technology EDR that's out there because their organization can afford it, the staff supports it. And then there's other organizations where maybe the funds don't exist for them to provide or purchase that type of device, and they look to open source. But maybe they can't add that open source platform to their network. So now what do we have? We have an organization that can't afford the latest and greatest. We have open source that's available that the organization doesn't want to take the risk of putting on their organization's network. So as a defender, as an admin even, or maybe as an incident responder, what do? You may feel like you're hung out to dry, but that's not necessarily the case. But why are we even looking to get some type of device? Well, we want visibility. We want visibility into what's going on in our network. If we can't see what's going on in our network, sure, we're going to say hey, all is okay, right? So we want to be able to highlight that, understand the normality of our network, and really baseline it as a whole. We want to put together some type of threat database, whether it's reputation-based or not, behavioral analysis, statistical analysis, and we want to be able to, in a fast perspective, go out there and handle or attend to these incidents within our network. So again, if you can't afford this or your organization hasn't provided it for you and open source is not an option, you may feel like your toolkit is like that. Now, I don't know about you, but if somebody came to my house to fix my sink, right, a plumber, and he came with a toolkit like this with nothing in there, I'd probably be questioning why I'm paying money for you to come. But I don't want you to feel like this, because really you do have something in your toolkit, specifically Windows and most recently cross-platform. You can probably guess what it is. Yeah, it's PowerShell, absolutely, right? So you have at least one item that you can put in your toolkit, and that one item is really an array of items, and it's neat. So really, how do we even get to that? Well, I'm glad you asked. Here's how we do that. Before we do that, let's get the disclaimer out the way, all right? Might be TLDR, too long didn't read, or it might be too small couldn't read. The real short of this is, I'm not saying commercial open source tools have no use. They absolutely do. But I would tell you, not every organization is arrayed the same when it comes to funds, understanding, buy-in into what you're trying to do in order to meet their intent and their goals. And when that doesn't exist for you, specifically more on the Windows system, but again, more recently cross-platform, PowerShell can give you some visibility. Can definitely do that. All right, so we'll start with IIS, Internet Information Services. So in a Windows Server build, there are these features and roles, and one of them is IIS. That is a Windows or a web server built into a Windows Server platform. We just have to enable that, and some organizations who have a web server are using that. The good thing about this is there's some good logging that we can get out of it. Things like the source IP, the URI, the method, if there's a refer. Okay, I'm digging it, right? Because I don't want to have an application, or I recommend you don't have an application that you don't have visibility into what's going on with it. The good thing is, if we host our website, which is by default CINIT pub, our logs will be there as well. And if we're not going to host our website there, wherever we are hosting it on disk, that's where our logs will be. So they are written to disk. That's cool. It is a text file, but the problem with it is very difficult to read. There's a format, but it's really unstructured ASCII, and you can control F or select string or find string, or if you're going to put it on a NIC system, you could grep your way through it, but that's very technical, and that doesn't scale very well. What I really want, personally, I want to get it to the event log, and I'll talk more about the event logs in a minute. But if we're logging, we can track, really catch potential incidents or potential misuse, recons, in which somebody's trying to start their campaign. But we could find ourselves lost in that. So here's an example of our IIS log, typically rolls every day. Very unstructured in a sense, right? Not a CSV of sorts in which we could parse it very easily. What I have highlighted in red are at least the fields. At least the fields. Okay, cool. So I'm not going to control F my way through this. I'm going to utilize PowerShell. I'm going to convert this flat text into an object, right? Yes, PowerShell is object-oriented. So we're going to convert this into an object in which I can select the properties or really attributes that I care about it. Okay, so that log, all that good stuff in it, what do we really have? Again, we have our system on the left trying to reach out to a resource on our web server on the right. They're calling upon the root or whatever that index is going to be. That request is successful. That data is returned back, so we get a response code of 200. We see them now calling upon index. That is successful. We get a 200. We see them calling upon whatever's hosted at /2021 design 200. Okay, awesome. Maybe these are things that I really want people to see. Maybe it's misconfiguration on my perspective. Maybe they've done a directory traversal and are just, navigating all the way around. Maybe I have stuff in robots.txt that I really don't want to be indexed, and somebody's like, well, you don't want to be indexed, I'm going to go look at it. But nonetheless, we have people just randomly doing this. Maybe automated in function or factor, but still, nonetheless, still doing this. So we have our first one, which is like our last one, but then we also have our second one where somebody's trying to grab whatever is being hosted at /DB on our site. Now, what's being returned here is a 404, so that resource is not found. Interesting. Then we have the next one where somebody's trying to grab command.php. Very, very interesting, right? Because command.php is typically a web shell. So I have somebody trying to maybe blindly grab to see if a web shell is there. Maybe they exploited on, and part of the payload was to upload this web shell, and now they're trying to go and access it. Interesting. So all of that's going to be in the logs, but if it's that flat text and unstructured, I'm probably not going to find it. I'm going to get lost in the data. Hey, yeah, I can control F, but again, not really for me at scale. So we look at our fields again. We converted this to an object. We now have properties and methods. So we have really the output of that. And we see the date, we see the time, we see all that stuff being highlighted in the red text box below and each one of the items below it. Now, if I cared about it, I could select a particular property, that red text box, and then I could specify the things I care about in there. And now that I have it in some structured format, if I don't have Elk, Splunk, or whatever else you're using for log aggregation, I can utilize out grid view in PowerShell, which is what we see here, and do some form of analysis. Okay, so I'm getting somewhere. When I'm looking at this and parsing it a little bit more, I start to see people grabbing other things that I would have missed. PHP admin, that's a nice try, not here, right? That's not what we're using. WP admin, that second red text box. Okay, not WordPress, because we're using IIS, but somebody's trying to grab in the dark. They're doing some type of blind scanning, blind analysis in the sense of just trying to get into our server. And then we get to the bottom, and then we have that command.php, and then we have shell.php. Again, somebody trying to grab what they believe to maybe be a web shell there. But those are all returning 404s. I could look a little bit deeper, or I could go on about my merry business. But nonetheless, I want to go a little bit deeper in this. And when I say a little bit deeper, really what I want to do is kind of group this stuff together. Is this a one-time occurrence, drive-by? Or is this something where people were seriously trying to get there over and over again? So breaking it down, we see our least amount of time, we see the most amount of time something was called upon, but really, this really highlights to me, just using this subset of a sample. We got shell and command.php, we got it from the same IP. Now I want to know what's up with that IP. Maybe it's Tor, maybe it's some type of redirection through some other device that doesn't know it's doing it, but nonetheless, I want to understand that a little bit more. And then that WP admin is there as well. But this whole PHP admin, there's 11 IPs that tried to hit that. Could be the luck of the draw, could be a little bit more. But nonetheless, I'm taking this flat text file, converting it to an object, parsing it, and we're doing this all in PowerShell. Could we get a little bit more with some other tool? Possibly, but I'm working with what I have. I'm still accomplishing what my task and mission is without saying that I can't actually do it. So we stack this, and we're able to determine the rate of least occurrence. Now, if we want to go a little bit deeper in this, any tool I talk about on here are tools that I developed. You'll be able to get them off my GitHub. All the code is already there. So we have invoke PS geolocator. Cool. So now I'm able to take IPs that I'm seeing in an IIS log, and now I'm able to get information about it as far as geolocation. We're able to utilize a free API from that site that's listed, and now I can pull IPs out of my IIS log and get some geo information about it. So in this case, I see my IP, I see the city, region, country, continent, all that good stuff. Depending on my organization, this may be all right. Or it could highlight things, right? And then if we are able to take this information and look up a little bit further, maybe from a reputation-based device, maybe reputation-based in our own environment, we could start to either say this is more suspicious, we need to further investigate, or maybe this is benign. But nonetheless, we can go a little bit deeper. Now, I would tell you, from the server in which we're using this on, I don't know anybody in Russia, in Moscow, right? And the service that's being provided should not be of liking to them. So I may go a little bit deeper in that aspect. Now, again, we're trying to do something with the little bit we have. And we can utilize virus total. Now, we're not going to upload any binaries to that, but we can look at utilizing scanning of files. Again, we're not going to upload binaries. Recommend you don't do that. But we could look at some hashes, we could look at domains, we could look at URLs, and kind of get a reputation-based analysis. All right? What does the rest of the community think about this if I don't have some type of internal reputation-based analysis for myself? Cool. Well, there's a paid-for service, but there's also a free service. That free service allows you to get an API, submit 4 requests per minute, and then you see how many requests per day. So there's some throttling in there. Now, I'm not going to do this with every IP. We'll look more at a specific suspicious perspective. And then let's say you wanted to look at all binaries, hashes on your disk. That's going to be very time intensive to submit it to virus total. But if we started to look at running processes on our system, right? What are the hashes of those, and then running those to virus total. And then, hey, if I've seen this before, writing it to my own hash table or dictionary list if you come from another language, right? Local, so that way the next time I get ready to run it, if I've already ran that hash once, I've already can say it's good to go. And now I have something across my organization of sorts. So we can utilize the invoke proc virus total scan. We can feed it hashes. We can have it just go off of running processes. And then we spit out how many you submitted, how long it's going to take. Again, I'm using a free API, so 15 seconds allows me to do 4 per minute. And then it doesn't matter if it's MD5, SHA-1, triple DES, if that's your thing, right? But then we start to get this information back. C by AV, the version of the AV that was used, whether it was detected, the result, because some AVs know viruses under different names versus other ones. We see when the last time that that file was actually updated, and we see that hash. When we parse this a little bit more, we bring it back in an actual table, and we can see our AVs on that first column, and then that subsequent information going across. Now, we see that my second hash, out of the 50 to 60 AVs, just off of this screenshot here, we have about 7 that said it was bad. For me, that causes concern, right? And then we can go a little bit deeper in there. And if that's the case, then I can proceed accordingly. But I'm taking hashes that I have, getting some reputation-based analysis off of it, and then I'm feeding my own reputation-based local system. Event logs. My. Event logs are awesome. All right. I think if we look at a methodology of sorts, it's log to the event logs, step 1, because that's a little bit harder for somebody to wipe. If they wipe that, that's going to generate 1102. There may be some special tools and stuff out there, but nonetheless, the second part of the methodology is to offload it to another server, right? Make it difficult for an adversary to do so. Well, we can look at PowerShell and utilize 2 commandlets. Get one event, that's going to do our classic logs, so like security, application, system, that also does our event technology logs and our event tracing logs, so the newer logs that are with modern Windows OS's Vista and above. Get event log only does those classic logs we talked about. Both of them have the ability to do it across a subset of machines, so that's great. We also have the ability to take exported logs and read them back in. Now I can generate some code, call it a parser, do it one time, and then run it against a subset of logs over and over again. As an analyst, I already know what I want to see and how I want to see it. I generate that code once, and then I reuse it many times. There are a lot of event logs. A lot of them are not logging by default. If I could only pick one out of some of the most interesting ones, in my opinion, man, 4688 process creation. I want to know when a process is started on my box. Maybe not at the moment, but if there's ever a time when that becomes of interest to me, I want to be able to go back and get that information. We would need to cut that on through auditing because, again, it's not on by default. But when we get that and we try to look at that event log, by default, we see all this googly garbage, right? We see the time, the source, we see the message, but really, I'm really getting the count in which a process started and not really getting the meat and potatoes. So we can expand that, and when we expand that, we see that message field. That message field contains the real stuff I care about. Cool, a process started. Thank you. I really want to know, what is the process name? What path? Were there any arguments? What started that process? All right, maybe what user? Notepad running this system, probably not a thing, at least in my environment. I don't know about yours, right? Could be. It's getting ready to be 2020. Things are different. All right. But again, those are some of the things I'd be interested in, and it's all in that message field. What we can do to really get that particular information, instead of saying, hey, look in the message field, and if it's in there, return the whole message field, we want to get really deep into the actual things we want. Well, we can utilize these things called, in this case, extended properties, and I've kind of expanded it here. Because for every item in that message field up top, we have these extended properties that we can expand and then call upon them. So then we can go in there and say, hey, give me that account name. Give me that process name. Give me that PID, right? Because we may not be able to get a task list or a process list and see the process running at that time. Maybe it kicks off, spawns something else, and then dies. So timing is everything. When we're able to dial into that extended property, we can then, again, pull out the stuff we care about. So for each one of these properties, for that process ID, we cared about the time it was created, whatever the process is, the command line argument, what account was tied to it, and then what the creator was. That's going to be the parent. Okay, awesome. I'm writing it to the event log. Again, if somebody wipes this, that's going to be 1102. I'm not taking into account some other tactics that can be done. But now that I have an event log, I want to ship that off somewhere else. But more specifically, this could enable me to see things. Take all this data I have, chop it down into something more manageable, feeding me the information that I need, making the nearly impossible or difficult stuff for me to see more easily visible and understandable, digestible. In this case, we have what we perceive to be netcat going out to whatever that IP is on quad 4, right? And it's being kicked off by command.exe. I wouldn't have necessarily seen that by just looking at the message field as a whole. And again, PowerShell being object-oriented, we can break it down into something that is more manageable for us. Using what's called out grid view, kind of like an Excel on steroids type view, we can look at it. But if that's not your thing, you can ship it somewhere else. You can do whatever you want with it now that it's in a better readable format. And then we have this. So let's say I'm malicious. I get on a system. I'm going to look around, see if something is logging, and if it's not, I may proceed on with what I came to do. When we utilize custom event logs, we could essentially fake out somebody of malicious intent because we're able to log things that maybe weren't loggable before, or maybe we just don't have on. For example, I go back to that previous example, right? I get on the system, I look to see if 4688 was being logged. It's not. That allows me to then maybe go ahead because whatever I bring may not be logged as a process created. So I have a false sense of hope. But the admin could be logging it as a custom log. Well, what do they name it? Whatever they want to. They can call it Nandynan or Augusta BSides, right? But likely, we would call it something that blends in with some of the other logging we have. And when we do that, we can write exactly what we want, how we want it to the event log. So I have this one that I call find notepad. I have an event ID of 1337 because, well, lead speak. And then really anytime notepad was started, I wanted to log the process ID and I wanted to log what user responded. But I could have logged whatever I wanted to in a fashion that I found which would make sense for me. So what's the methodology for this? Well, first you got to retrieve the data. Then you got to filter it for what you really care about. Once you have it, send that bad boy to the actual event log in the format that makes sense for you. And this is going to be as an object, so we can then take it and do something with it later on. Now, as an option, because we talked about getting it off of the system, hey, we could use something like Slack as a log aggregation server. Now, this will not work in every environment because, again, I write it to the event log. I'm taking some risk by leaving it there. I really want to get it off of the system. So utilizing Slack, we could, in near real time, get it off the system on another platform. We could also ensure that it doesn't get wiped locally. Now an adversary would need to gain access to our portion of the Slack platform to get access. But there comes some cons, right? It is definitely stored on somebody else's server. If you look at the terms of agreement, probably not in there, right? Probably not something you should be doing. But there could be some transient concerns. And again, this is definitely not for enterprise use. Now I have to be a little bit diligent in what I'm actually looking for and what I care about. So in us testing this, I utilize just this little bit of code. This little bit of code allows me to send a message of howdy. It allows me to send it under a bot name of logger. And then I have my API that I obviously don't have up there on the screen, but that's the URI that Slack provides to me. And then I have the arguments based upon their API documentation. Once I do that, this is what I see in my Slack channel. Logger, howdy, and then that channel is Jen. Okay, all right, okay. Now I'm gonna go a little bit further. Now I'm going to actually retrieve some data, filter it for items that I care about, write this data to the event log, because that's step one. Then I want to monitor for those event logs being written as, and then I want to send those particular things off to Slack. Again, not in every event type thing. But I'm trying to make it difficult for somebody trying to clean up their tracks. Now, from that, this is the code that allows me to do it. And really the meat and potatoes of this is where I'm filtering for the events. Largely speaking, it's the previous code, but now I'm looking at that aspect. And then what do we see? Well, we see this in my Slack channel. Time created, process, command line, the account, the creator, the same thing that we had seen previously when we were parsing it. Now I've got it in Slack. The things I care about that's going to keep me up at night, or maybe generate be a resume generating event, right? Some visibility. And in this case, we see defend 64 being kicked off by, what is that, cache 64? Hey, let's be real here. You throw 64 or 32 on most binaries, a lot of people will be like, that looks legit. Let's go on about our business. All right? Then we see some PowerShells and some stuff that probably should not be happening down below. Now you talk to any defender, right? Anybody in this space really, and they'll tell you that probably processes and connections or netstat are important. I'm not going to tell you any different. They absolutely are important. From a PowerShell perspective, we could use get process. We could also use get net TCP connection. That's going to be a V5 or newer feature, that last one. But we get a lot of great information. And what we want to do is really take that information and put it together. Because independently, we have information, but now we need to go run this again, go back over here and look at that. We want to correlate it together. We really want to join it. Now, if that doesn't make sense, I present to you this. Everybody loves Reese's, right? I mean, let's be real. This was awesome, like mind-blowing, right? You got Reese's cups, you got Reese's pieces. You put it together, and it's like slow clap. Like, why didn't I think of that, right? So we're going to do the same thing with our processes and our connections, and I call that get verbose process. All right, giving me that clearer sight, reducing some human oversight. Like as I look at processes and I remembering what I care about, and then as I try to transition over to connections, maybe I can't remember if that was a 1 versus a 2. That's too much. I want to put it all together in one visual aspect that a user, an analyst, can actually see and comprehend. And then guess what? If my organization gets me a SIM log aggregation server, I can easily export that and import it into that. So what does that look like? Well, we have 2 individual instances that we're looking at, hence the 2 red boxes, and we see the local IP, local port, foreign IP, foreign port, okay, for each one of them. Again, 2 individual connections and processes. And then we see whatever that process is, to include the PID, the process command line itself, where it's running from. Like SVC host should not be running out of C windows or a user's path. But guess what? We also see that hash. Let's go ahead and hash that thing all at the same time. Okay. And then if we want to add a little bit more code to it, we can look at that reputation-based server that we're already doing from a VirusTotal perspective. Okay. But what started this? Because there are some things that it just doesn't make sense that it would start it. So then we get that as well. We get that in one picture. I'm not doing a swivel chair trying to tie it back together. I get it in one picture. Now I should be a little bit more deadly in my analysis and my approach. Anybody using McAfee products out there, McAfee Virus Scan, when it finds something that's malicious, it says it deletes it, but it doesn't really delete it, it quarantines it. And by default, that's written to C quarantine. Now, it encrypts it, so it makes it unusable to the user, and it's really just XORing it, so exclusive XOR, or exclusive OR. But really what we want to do is understand why it quarantined it. Maybe, right, I implement a new item, I run it, and then it quarantines it. Cool, it shouldn't have been bad. Let me understand why. Or maybe somebody else infiltrated my box, McAfee caught it, quarantined it, but now I don't have that binary sample because it makes it unusable to the user. We want to get that raw binary so we can do some analysis on it. Either determine whether it's good, determine it's bad, but definitely McAfee don't just take it from me where I can't do anything with it. But thanks to McAfee, they published their key online. So now we can reverse their encryption tactic. And that stuff is going to stay in the C quarantine for 28 days by default. So we're going to take a binary, subset of binaries that have been buffed, and we're going to reverse that. I can't tell if you can see that very well. Can you see that very well? Okay, awesome. So I got a number of things that have been buffed. They're unusable to me. I want to reverse that. So I'm going to utilize some PowerShell here. And we're going to do unvoke unbup. We're going to specify our path, and we'll specify our quarantine folder. It's going to run, and then it's going to reverse that process. Now, if I'm doing this on the very system it triggered on before, it's just going to rebuff it. So I'm going to zip it, password protected. Most people would do something like malware. I'm going to call it infected. But that process is done. So now when I come in here and look, I start to see that raw item. Looks like this one, it was being downloaded from Google Drive. It was still in the process of being downloaded, and there was a certain part of that probably executable in which it triggered as being bad. All right, but now that we have this, we can go in there and actually look at it. Again, we wouldn't do this on the very system that we have antivirus running on. We would do this on our actual analysis system. And then we can make a determination. Was this really bad? Oh, this is bad. This is good. Right? Let's grab this, and now we have that raw binary sample. Thanks, McAfee. I can't say that too often. But nonetheless, we can utilize that. Okay, here's another one. PowerShell Rapid Response. I recall going into an organization as an incident responder, And I'm like, cool, I'm here to help. I got all these great tools. I want to put this on your network, and I'm going to find badness. And when I'm done, guess what? I'm going to take my tools back, and now I'm going to leave you. Oh, you're been infiltrated again? Cool, I'll come back with my tools. I'm not really helping you long term. So I came up with PowerShell Rapid Response because in a Windows environment you have it. So it's going to be an incident response framework in which the defender, the local person, can actually start to defend their network, not call upon me as much, right? But also really empower them. This is going to help them with identifying anomalies across their network. There's right now roughly 20 items of interest that I care about, but it's extensible through plugins. So if there's something particular that we don't have in here, add it in there. Right? It's open source, it's on GitHub, so do a pull request and then help with the project. It utilizes the pull method. So if you pull every 30 minutes, you could be missing stuff. So it's not necessarily near real time, but it absolutely gives you some visibility without having an agent on the box. That data is going to come back as a CSV and also in a SQL database. It uses a network logon, so we don't have to worry about Mimikatz or anything like that. We start to see really some of the things that we can get utilizing PowerShell Rapid Response. And then when we look at actually running this, we have so. So I'm going to run it. We got a number of options. I can pull it straight off of all my systems in AD. I can feed it a text file. I can input IPs, or I can do my local machine. I'm going to do one machine, so I'll select option 3, put in that IP, and then it's going to run. All right? It's threaded, so it's not going to be one after the other. Now, as that's running, I've already ran this before, so we can start to look at some of our old data. Every time this is ran, it creates a directory with the actual CSVs from that run. So maybe you want to take that, import it into Splunk, Elk, read it back into PowerShell for analysis, or just really identify a particular instance. From a larger perspective, all these items are written to a SQL database. So I can, if SQL is your thing, you can conduct some analysis utilizing that. And that gets appended to. So there's going to be one database that's for application events, or there's one database that talks about drivers or disk information. And I'll just utilize just SQLite here, and we'll open one of these databases. Let's say drivers. All right, and I can start to do my analysis. Maybe this is the way you want to do it. Maybe you want to take these databases, load it up as part of a backend to a greater front end for visualization. But at the core, we're giving you options here. Get the data you need, conduct the analysis you want to do, and really highlight the things somebody is employing you to do. All right, I got an error there. All right, so as we look at DNS, really the methodology, or really the process, is as such. User navigates to, let's say, google.com. The system searches its local host file. If there's an item in there that points to that domain, it then tries to navigate to that IP. If not, it checks the local DNS cache. If it's been resolved before, it then navigates to that IP. If that's not the case, it looks at whatever DNS server it's tied to or pointed at, and then that DNS server checks its cache. If that URL or IP is in there, it didn't respond. If it doesn't, it checks to see if it's authoritative for that domain. If it is, it responds with the IP. If it's not, it will look at root hints or a forwarder. Just really depends on how that DNS server is configured. So with us understanding that at a high level, we recognize that some malicious folks look to use domains in their malware. All right? We want to affect that. We want to limit that and really reduce it, contain it, if you will. based upon that process, we really have two places. I could go into a host file and list out domains and say, hey, they resolved to loop back. That's cool when I have one or two machines. When I got an enterprise of machines, look, in the famous words of that one lady, ain't nobody got time for that, right? So what I need to do is look at trying to do it from an enterprise perspective. And we can do that with the second orange box. We're going to utilize our DNS server, check to see if it's authoritative for that domain. And if it is, we're going to do something with it. Call it synccolon. Synccolon? Yeah, check this out. We have a car driving that's trying to get to that building over there. There's a sinkhole there. They're going to either stop or go into that sinkhole, but either way, they're not going to get to the other side. Okay, I got it. So we're going to utilize a method that allows us to do that. We'll run invoke sinkhole domain. We'll utilize individual black hole domains that we want to use. Maybe we input those in. Maybe we grab them from some reputable site, something like malwaredomains.com. And then we're going to create what's called a forward lookup zone in our DNS server. That's what's going to allow us to become authoritative for that domain. And then when we resolve that domain, we're going to put in there that the address for it is quad zeros. It ain't going nowhere. We've essentially sinkholed it. Now, if the malware author wants to use IP addresses, cool. But guess what? Domains allow them to be a little bit more modular. IP addresses, they're probably going to have a list, right? It's going to be a cat and mouse game. But when we look at actually adding this into our DNS server, we see a number of domains that we've added off to the left, and then we see our DNS A record for IPv4. We could do quad A's as well for IPv6, but we see we're resolving that to quad zeros. Quad zeros. So we're sinkholing that communication. Awesome. Now we're doing this from an enterprise perspective. And let's say we've identified the malware, we see it's running, we probably have some type of conversation about it, and we don't really want to stop it because we don't necessarily know what's the next steps. Maybe it tips off the malicious author, or we just want to understand it a little bit more. We could pause that process, or really suspend it. And the way we do that is we attach a debugger to it. All right, cool. Now, the real point of this is we need to at least have the SE debug privilege, but this allows us to pause and really suspend a process. And we can, when we suspend it, we could get ransomware keys if ransomware is what we're going after, and we could really ensure we don't break critical processes. So when we really utilize this, we're going to do something like so. I'm going to have a binary that literally just prints out to the screen that it's calling home, even though it's not. So every second, it's just going to spit that out, just enumerating, adding. So we'll run invoke process suspend. Actually, we won't run that first. We need to identify the PID of this thing. We see the PID is 8720. So that's the one that we're going to pause. So now we can come back in here and we can suspend it, 8720. And when we've done that, we noticed that process is stopped. And it's still running, right, in the context of it's a process executing, but it actually doing stuff because we have a debugger attached to it, not so much. So now we can triage, understand a little bit more without fully stopping it. And then when we're done doing that, we can resume it, specifying our ID, and then we see it continue on. All right? A tactic, a thing that we can use to kind of aid us in our incident response process. All right, who in here's heard of fail to ban? All right, cool. I like it. Sir, you've heard of it, right? Okay, all right, awesome. All right, so I like it. All right, it does what I need, especially from an internet-facing thing. But hey, not everything runs on NICs. So from a Windows perspective, what do I have? There's some items out there, but they don't really get after the full complexity of what I'm trying to accomplish. So end up coming up with invoke fail to ban from a Windows perspective. All right, and really what that allows us to do is essentially everything that fail to ban does, but it writes to our actual event log, then it writes to, you guessed it, SQL database, right? Because I want to give the analyst options for interoperability with other tools or capabilities they may have. But this allows us to have some oversight into our internet-facing items without allowing somebody to just tag at them every second of the day. So how is that being done? Well, we'll utilize this diagram. We got the system on the left trying to log into the system on the right. First time he tries admin 123, the red signifies that that password was wrong. All right? And then he continues on, then he gets to the point where it's admin P $, and it was right. So he tried a number of times and he was good. Now, they could have had on there a lockout threshold based upon the number of times somebody entered a password, then locked them out. But let's be real here, that may not always be the case. And then guess what? Maybe it only locks them out for 60 minutes. When we use invoke fail to ban, we can set our threshold. We can customize really finite in the sense of how long we want to lock them out. And it's all automated for us. All right, so we see this person trying to log in 3 times, and now it blocks him, so he no longer communicates with that machine. So we'll do that, and we'll look at that. So we'll come in here with invoke fail to ban. I'm going to run this. I got a couple options. I can just start monitoring. I can list whatever banned IPs and I have in my database and whatever that status is. We could also list our whitelisted IPs because let's be real, you definitely don't want to lock yourself out. Or we can just say in a hasty manner, let's unblock everything. So I'm going to select start monitoring. And then I have the option to, outside of whitelisting my own IPs, but I have the ability to add additional IPs. No, I do not want to add any more. It returns to me all IPs associated with my system. I'm going to press enter to start. I'll come over here and I'll try to log into that machine 3 times. Right now I have the polling rather aggressive just for the demo. All right, cool. So it triggered, and now when I come over here and look, I see a ban for that IP that actually tried to log in. I get to the point where now I go look at the event log. I see the data that's in there that I care about, and it continues to monitor. And then once that threshold has been met, as far as how long I want it to actually lock that system or block that system, it releases it. All right, so we see it's now been released. We refresh, that rule is gone, and we're good to go. Now, if we get to the point where it's like, hey, I want to look at this a little bit more. What other items do we have? We can go in there, and I would see right now we only have 1 IP in that database, and we see currently it is not being blocked. Okay, so we got a couple of things here that we can add to our toolkit, right, within PowerShell. I'm feeling good, feeling accomplished. But there's some pitfalls, right? Trust but verify. Somebody wants to tell me that. Actually, I heard that again yesterday. Trusting PowerShell and Windows API. Man, if that system is really compromised, if it's really, really compromised, I don't know if I'd want to trust a binary that's already there. Definitely, I feel a little skeptical about Windows APIs at that point. But if I'm proactively looking and trying to identify maybe patient 0 or who else is infected in some respect, right? Maybe I'll utilize this. My knowledge will vary. My organization will vary. The tool sets I have will vary and really depict this. Not every network may be utilized or configured to utilize PowerShell remotely. If that's the case, then you may find yourself going from system to system, and then that kind of defeats some of the purpose. And then PowerShell may not answer every need. Nothing is a 100% solution. But I tell you, I was once sitting there with nothing, and now I've been able to answer some information. So, right, our knowledge will vary with that, as long as we understand that. Some other useful frameworks and scripts. Each comes with their pluses and negatives, some overage, but definitely worth taking a look at. A lot of work has gone into these things. All right, so as we wrap up here, you started with the toolkit like so. Now your toolkit's like that. Yeah, ooh, ah. All right, now if you show up as a plumber at the house, I'm like, yeah, man, sink's right there. All right, but guess what? What you don't see in there. Yeah, you don't see that. So I got one more thing I want to add, really that times 3. The first is the PowerShell cheat sheet. I don't care what language you code in, script in, program in, right? Nobody starts off remembering everything. So here's some core aspects for PowerShell, one cheater, if you will. And then slowly but surely, maybe you get off of that. You're like, I don't need that anymore, right? But a good reference sheet. Now, I did this back in 2017, but it's still very relevant today, right? So your mileage will vary with that, but a good starting point, in my honest, humbling opinion. And then guess what? If you're looking for realistic, on-demand, 24/7 free, FREE, capital lowercase, mixed, it doesn't matter, free is free, right? Under the wire. Myself, 2 other people, developed it back in 2015. We got over 70,000 people, unique people, who have played this game. Roughly 78 countries of the 193-ish countries. All right, cool. So this gets after the core aspects of PowerShell. Hey, I want to look at a file, or I want to filter for this, right? This is exploratory learning with the purpose and a goal in mind. And then if you're like, I'm beyond that, then I implore you to really use Posh Hunter. Posh Hunter allows you to have an actual VM. The VM has artifacts, has some beaconing going on, just benign beaconing, right? But there's 90 roughly challenges in which you jump in this environment, utilize some PowerShell, situational based, and you'd answer questions. Call it a CTF on demand if you want to. Posh Hunter is nonlinear, whereas Under Wire is linear. All of these challenges were based on first-hand accounts, right? The names were withheld to, secure identities and all that good stuff. But free. All right, so summary. Commercial tools are great. They very much are. Very much so. If your organization can afford it. Okay, true. Open source tools are great as well. Very much so. If your organization will allow it. Fair point. PowerShell can provide access to vital data. I don't think anybody's going to combat that. Enabling you to do more with less. Absolutely. People want results. Incident response is a results-driven field. Everything comes with a con. PowerShell is no different. So I want you to really realize that. Now, that brings us to the end. If you want to connect with me, that's how you do it. I'll pause for a minute for questions. Now what? Oh, all right. Who's the youngest other than my daughter? Who's the youngest in here? Who's 17 or younger? Come up, please. Who is 21 or younger? Come on up. 23 or younger. All right, come up. How many I got? Oh, here we go. All right, let's get the youngest one. I'm answering a question still as we do this. How old? 14. 14, how old?
19. 22. 21.
Somebody was 21. Sorry, I apologize. You can shank me in the hallway. All right, hey, thanks for coming up. All right, any questions? If not, that concludes my brief. I'll stand by in the corner. Thank you all. Okay, we got a question. It's coming. I'm in the process now of highlighting something like PoshR2 from a Linux perspective. Not necessarily Mac, but yeah, absolutely from a Linux perspective. Open source in PowerShell was probably one of the greatest things that happened. So the question was, have we started applying anything like that towards Mac or Linux? And the answer was definitely towards a Linux perspective. Sir?
How network intensive is like running PowerShell pulling multiple workstations?
Yeah, so the question is, how intensive is PowerShell across an organization running and trying to grab this information? And I would say It really depends as long as it's done smartly. It has the ability to do jobs, so it's threaded out, and as long as you're not like, connect to this machine, grab that one thing, connect back to that machine, grab this one thing, it's not necessarily as bad, right? And if you have decentralized organizations, maybe you put some of the code you're looking for on a local server in that actual geographic location and have systems grab it from there, and then have that one machine come back to another geographic location, as opposed to a machine in Seattle going all the way out to Atlanta or New York. But your organization will definitely vary based upon bandwidth and everything else. Good question. Any other questions? All right, thank you. I appreciate it.